Okay, let's look at question 16. A high school developed a program called Propel, which offers extra guidance and support during the 9th grade year. Before the school year began, 327 rising 9th graders were selected at random to participate in a study. 109 of those students were randomly assigned to enroll in the Propel program. So these are all the 327 9th grade students, and there's 109 who are enrolled in Propel. I'm going to quickly calculate how many who are not enrolled. So 95 plus 123 is 218. Actually, I think I'll do totals for all of these. So in other words, 3.0 or greater, well, let's finish reading. 109 were randomly assigned to enroll in Propel. The remaining served as a control group. A summary of the year and grade point average for the 327 9th grade students who were chosen for the study is shown in the table. So it's a lot of reading here, and the questions are not super difficult, but you do need to be careful you're picking the right category. Okay, I'm going to do a total for 3.0 or greater. So 61 and 95 is going to be 156, and then less than 3.0, 48 plus 23 is 71. Okay, so I've got my totals here and here, and then the total for everyone is 327. So let's look at these questions. If a 9th grade student at the high school is chosen at random, which of the following is closest to the probability that the student will have a GPA of 3 or greater? So out of 327 students, how many have a GPA of 3 or greater? So that's going to be 61 plus 95, this total, 156. So the probability that the student will have a GPA of 3 or greater, 3.0 or greater, that would be these students here, whether they're in the program or not in the program. The 156 students have a GPA of 3.0 or greater. So 156 out of the total 327. So about 48%. So B. Number 17, what's the difference to the nearest whole percent between the percentage of students enrolled in Propel who had a GPA of 3 or greater and the percentage of students not enrolled in Propel who had 3 or greater? Okay, so this is two amounts that we're looking at. The percentage of students enrolled in the program who had 3 or greater. So I'm only looking at this column right here. 61 students in Propel out of 109 students had a GPA of 3 or greater. So let's see, 61 out of 109. These are the kids in the program. And then the ones not enrolled in Propel who had 3 or greater. Then I'm looking at just this column. So out of the 218 not in Propel, 95 had a GPA of 3 or greater. So I'm going to look at those two percentages. So as you can see, these are reading heavy. We'll get a little practice with this before the test, but they're not super difficult. 61 out of 109, that's about 0.56. So 56, let's say 56%. And then 95 out of 218 is about 44%. So if I were to look at the difference between those two, 56 minus 44 is 12. So that would be D, 12%. 18 of the students enrolled in the Propel program. Okay, so I'm only looking at these 109 students. The ratio of boys to girls is 2 to 3. Okay, so boys to girls is 2 to 3. Which of the following is the best estimate of the number of girls in the program? So I want to know how many girls, if the ratio of boys to girls is 2 to 3, how many girls make up this 109 students? Well, if the ratio of boys to girls is 2 to 3, then the ratio of girls to total, there's 3 girls for every 5 students. So see if that makes sense. If boys to girls is 2 to 3, that means you're looking at a total of 5 students, and 3 of them are girls. So 3 out of 5 are girls, and I want to know how many out of these 109 that are in this program would be girls. So I'm going to say how many out of 109 are girls. Now that's a little bit challenging, but with practice you would be fine. So let's do 3 times 109 divided by 5. So 65 would be girls in Propel. Number 19, so we're on to a different topic. An artist is creating a sculpture using bendable metal rods of equal length. One rod is formed into the shape of a square. The other rod is formed into an equilateral triangle. So these 2 rods are equal length. One is turned into a square. All sides are equal. One is turned into, now I've done this problem already. If I hadn't done it, I probably wouldn't draw it bigger than this one, but it's turned into an equilateral triangle. And it says if each side of the triangle is 2 inches longer than each side of the square. Okay, so draw these 2 pictures in your notes for turning in. Okay, I'm going to call each side of the square X. And it says if each side of the triangle is 2 inches longer than each side of the square. So if this is X, this must be X plus 2. How long in inches is each rod? So we know that they took the same amount of rod here. Now I drew them differently. I know this total amount probably doesn't look the same as this total amount, but that's what this problem is saying, is that this total amount is the same as this total amount. So that means X plus X plus X plus X is going to be the same as X plus 2 plus X plus 2 plus X plus 2. So my equation would be 4X equals 3 times X plus 2. The amount of rod used to make the square is the same as the amount of rod for the equilateral triangle. So that's going to give me 3x plus 6 equals 4x. Subtract 3x from each side, so x equals 6. And it's saying how long is each rod? X is 6. 6 times 4 would be 24. Now you might be saying, oh, that's a hard one. Maybe when you start out it's hard, but if you practice that type of problem, and if we do another practice test, it actually, you start to see the simplicity of it. Okay, for number 20, this one I will tell you is a little bit challenging just because of how it's worded. A rational function is defined above. Which of the following is an equivalent form that displays values not included in the domain as constants or coefficients? So when I first read this problem, I thought, includes, displays values not included in the domain as constants or coefficients. A lot of students are going to look at that and go, what the heck are you talking about? So let's say you see a problem like this. You know you're trying to figure out the equivalent form. You're trying to find out which one of these is the same as this. Now this little part here might be confusing, so I'll clarify that. But you can quickly figure out some choices that are not going to work here. So I'm going to take this equation, and you're probably noticing the questions are getting more challenging. Whoops. Over 2x squared plus 2x minus 4. Now, this is one where if you're under pressure, I would say skip over it. It is a little bit more challenging, and there's others that you're going to know. But if I were to do this, I would factor out the common factor here. So there's a common factor of 2. 2 times x would be 2x. 2 times 2 would be 4. So this is going to factor into 2 times x minus 2. This has a common factor of 2. That's going to factor into 2 times x squared plus x minus 4. Now I'm looking at the choices, and I see that this matches this, except those 2's aren't there. And then B, it looks like they factored it a little bit further. So at this point, I'm going to say, okay, can I factor x squared plus x minus 4 really quickly? I think I can. That's going to be factors of negative 4 that add up to positive, oh wait, this should be a 2, sorry. Where am I getting that for? Factors of negative 2 that are going to add up to positive 1x. So that's going to be 2 and 1, 2x and 1x, and I want the 2 to be positive. So that's going to be 2x and negative x, which is going to give me x minus 1 and x plus 2. So this would factor further into 2 times x minus 2 over 2 times x minus 1 and x plus 2. So this is homework right now. Work it out with me. If it's too much when you see something like this in the test, it's okay to skip over it. So if you look at the choices, this matches what we have. And this is showing values not included in the domain. Now you might be thrown off by that, but domain is all the possible values that we could use, all the inputs. We haven't talked about domain and range very much this year. Negative 2 is not in the domain, because if I plug in negative 2 here, I would get 0 in the denominator, and I can't have 0 in the denominator. 1, not in the domain. So the domain is all real numbers except negative 2 and 1. So this is showing numbers that are not in the domain as a constant. That's what they're referring to there. Now that is a little bit different than what we usually don't talk about writing an equation with values that are not in the domain as constants. We would just say factor it. So let's move on from that one. That's a lot of time on one problem. Let's look at 21. A landscaper is designing a rectangular fountain with a 4-foot wide path around it. So you've got a rectangle, and you've got a path around the rectangle that's 4 feet. The equation A equals 4p plus 64 will relate the area in square feet of the path to the perimeter in feet of the fountain. In the design, how many feet will the perimeter of the fountains increase for each additional square foot of the past area. So actually, we didn't really need to draw this. I always draw things when I'm reading about a figure. They're asking me about how the perimeter is going to increase. How many feet will the perimeter increase for each additional square foot of area? So they actually want us to take this equation and make it an equation for perimeter. So let's start with A equals 4P plus 64, and let's solve for P. So if I'm solving for P, I would subtract 64 from each side. That would give me 4P equals A minus 64. And then I would divide by 4 on both sides, which would give me P equals, now I'm going to write this a certain way. Technically this is the answer, but you might not see what they're asking about if I write it like this. I'm going to write it as 1/4 A minus, so I did A over 4, which is 1/4 A. 64 divided by 4 is 16. So they're asking how many feet will the perimeter increase for each additional square foot of area. They're looking for the slope of this equation. And the slope of this equation is 1/4. So for 21, the answer would be 1/4. Okay, for 22, in the xy plane, the graph of a function q is a parabola. This one's actually very easy if you know what they're asking for. This might throw you off right here, so let's break this down. The graph intersects the x-axis at -1, 0 and r, 0. If the vertex of q, okay, and q is just the name of the parabola. Instead of saying y equals ax squared plus bx plus c, they're saying you have an equation and you're calling it q instead of y. That's all that is. If the vertex occurs at this point, what's r? So this is actually very easy. Here's my first x-intercept, -1. My other x-intercept I don't know, but I know that the vertex is at 2, 4. So the vertex is up here somewhere. Well, isn't the vertex right in between the two x-intercepts? So my x-intercept, okay, so the vertex is right in between those two x-intercepts. So if the distance from 2 to -1, that's 3. So I know the other x-intercept is going to be 3 units away from the vertex. So that's going to be at 5. So my other x-intercept is at 5. Okay, number 23, liquid going through a cooling system is chilled so that its temperature decreases at a constant rate. So we're talking about a linear equation, from 100 to 25 in 5 seconds. So that's a decrease of 75 degrees in 5 seconds. 75 divided by 5, that's 15, so it's a decrease of -15 degrees per second. Which of the following functions represent the temperature in degrees Celsius as a function of time after chilling began for 0 to 5 seconds? Well, it started at 100 and it's decreasing 15 degrees per second. So the only one that shows a starting value of 100 and a decrease of 15 per second is D. So that's just a basic linear equation. I know it's kind of hard to go from a word problem to an equation, but some of these you could quickly eliminate by just kind of comparing and contrasting. Okay, 24, the formula shows the formula for the volume of a sphere with radius r is shown above. The radius of Jupiter is 11 times the radius of planet Earth. Now this might be one you say, I'm going to skip. That's fine. This one is something we really haven't done yet. I'll show you how to do it. If it's something like this on the test and you're overwhelmed with it, just skip over it. Remember, half of these, if you get even half of these right, you're going to be in good shape. So the radius of Jupiter is 11 times Earth. Assuming that planets are spheres, how many times larger is the volume of Jupiter than Earth? So I'm going to put in the place of R, I'm going to put 11R. So the volume of Jupiter would be 4/3 pi times 11R to the third. And it's asking how many times larger is Jupiter than Earth? Well, if I do 11 to the third power, that is 1,331 r to the third. So I get that the volume of Jupiter is 4/3 pi times 1,331 r. Well, that's the same as 1,331 times 4/3 pi r cubed, which was the volume of Earth. So Jupiter is 1,331 times larger than Earth. Okay, 25. Population of squirrels has been doubling every 15 years. There's the clue right there. If you look at these choices, exponential, linear. They want you to decide, is this exponential or linear? Did the rabbits, remember the rabbits, the bunnies, they doubled? That was one of our first examples on exponential growth last year. So we know it's not going to be linear, and I haven't even finished reading the question. I should finish it. Which of the following statements describes the type of function that best models the relationship between the population of squirrels in the park and the number of 15-year time periods? Well, we know it's not linear. Doubling is not linear. And my two choices are exponential because the population is increasing by the same amount, or exponential because the population is increasing by the same percentage. Exponential increases by the same percentage. If it's increasing by the same amount, that's linear. So it's fine if you just put 25 and B. If this function is defined, 3x squared minus 5x plus 4, what's f of x minus 4? These are actually easy. They just might take you a little while. And under pressure, that can be a little challenging, but if you take your time setting this up, it's not too bad. Okay, x minus 4 squared. If I square x minus 4, I get x squared minus 8x plus 16. Now all of that is being multiplied by 3. I'm going to go ahead and distribute this. That's going to give me minus 5x plus 20 and bring down plus 4. Then I'm going to distribute the 3. So 3x squared minus 24x plus 48 minus 5x plus 20 plus 4. So 3x squared, can't combine that with anything. I have negative 24x, negative 5x, that's going to be negative 29x. So you know it's going to be one of these. Positive 48, positive 20, that's positive 68, plus 4 would be plus 72. So that would be D. So write all this out when you turn in your work. 27. The equations of two lines are shown above. If the lines are graphed in the xy plane, which of the following ordered pairs represents the point at which the lines would intersect? So you're looking for a solution to a system of equations. when we solve systems of equations, if we had a variable by itself, substitution was usually the method we chose. Now, I would recommend getting rid of the fraction and making life a little bit easier. So that's easy to do. If I multiply both sides by 3, I get 3x equals 3 times 1 over 3 is 1. So I get 3x equals y. And I'm just going to take 3x and substitute it, trade it out with y. So that's going to give me 154 minus 4. And when I see y, I'm going to put 3x equals 10x. So 4 minus 12x equals 10x. Add 12x to both sides. So I get 22x equals 154. Then divide by 22. And that is 7. So I don't even worry about the y coordinate. I know x is 7. I mean, you could probably just guess on that 154 divided by 22 is 7. If you were in a rush, you would know it wouldn't be the other choices. Now, saying all of that, you do have a calculator. You could do this different ways, but I think that's probably the fastest way. If you want to review systems of equations, that's something we could definitely do after school. Okay, let's look at these last few questions. They're grid in. Remember, a fraction would be written like this, decimal like this. If you get 2/3, you could write it like this. You could write it as a repeated decimal. You could also round it off. So you can cut it off, you can truncate it, or you can round it off. Doesn't matter if you get something like 201 if you start here or if you start here. Okay, number 28. The grocer carries 2 types of frozen meals. And you know what? When you get to these gridding questions, you're going to be pressured for time. Maybe look at the 4 questions that are left and say, where am I going to put my time here? What looks like the easiest one? 29 looks pretty darn easy. This one, you might say, you know what? This is a lot. I'm going to skip over it. That's fine. But go ahead and go back to it if you do have that time. Okay, I'm going to show you how to do it, but just kind of keep that mindset of picking the ones that you can do before you waste a lot of time with something when you could have gotten this one right. A grocer carries 2 types of frozen meals that have fat and carbs content shown in the table above. John wants to purchase a combination of the 2 types of meals with no more than 350 grams of fat and no more than 2,975 grams of carbs. If he purchases 10, okay, he's going to get 10 of these, 10 of these. What's the greatest number of stir-fry meals he can purchase so that his combination will satisfy the requirements? So this really isn't super difficult. It's just kind of a lot. Okay, so if he gets 10 of these, he's going to have 50 grams of fat, and he's going to have 350 grams of carbs if he gets 10 of the Szechuan meals. And he wants to get a combination of stir fry and Szechuan. Okay, so he's going to get this amount of fat and this amount of carbs if he gets 10 of these. And we want to figure out, okay, if he doesn't want more than 350 grams of fat, how many stir fry meals can he get? Well, he's already getting 50 grams of fat with the 10 Szechuan meals, so that means the stir fry, he can only have 300 grams of fat. And each stir fry meal has 4 grams of fat. So 4 times how many meals is 300 grams of fat. So 300 divided by 4 is 75. Okay. If he gets 75 of these meals, 75 times 40 is 3,000, but he only wants 2,975 grams of carbs, and he's already going to get 350 grams of carbs with the 10 Szechuan meals. So I'm going to look at this 2,975 and subtract 350, because he's already the 10 that he's purchasing. So we don't want the carbs to exceed 2625. So let's do how many meals times 40 grams of carbs would give me 2625. So I'm going to do divided by 40, and that's 65.625. So if he got 65 stir-fry meals, he would have 26. He would not go above his carb limit. And let's do the fat. So he's not going to buy 0.625 meals. So let's just do 65 times 4, and that would satisfy the amount of fat grams. So the most he could buy would be 65 grams or 65 meals for stir-fry meals. Now that is kind of a lot. For some of you, you're probably thinking it's not too bad, but if you're like, whoa, that's a lot, I'm just going to skip over that and come back to it, then you have less pressure because you know, okay, I did the ones that I can do for sure. 29. If this is a solution, if xy is a solution, what's one possible value of the product of x and y? This is actually pretty easy. If you're looking for a solution to a system and they're both written in terms of y, and you have a calculator, you could graph these two equations and see where they cross. That would be an easy way to do it. If you're not comfortable with all of the graphing, because maybe that's the calculator you're used to or not, you could quickly set these two equations equal to each other and solve for x. So I'm going to subtract x from both sides, and I'm going to add 1 to both sides. That's going to give me x squared minus 5x plus 4 equals 0. And if I'm looking for the solution, I would quickly factor that. So I'm looking for factors of 4x squared that add up to negative 5x. That's going to be 4x and 1x. And I want them to be positive when I multiply, negative when I add. They're both going to be negative. So that's going to be negative 4x and negative 1x, which is going to factor into x minus 1 and x minus 4. Now I realize I'm going kind of fast here. If graphing is easier, you could graph these two equations and see where they cross. Those are the x-intercepts. Okay, whoops, x minus 1 and x minus 4. So that means my solutions would be x equals 4 and x equals 1. If x equals 4, I'm going to plug in 4 right here. 4 minus 1 is 3. So when x equals 4, the y coordinate is 3. When x equals 1, 1 minus 1 is 0. So my other solution is 1, 0. So that's not the answer to the question. The question was, what's one possible value of the product of x and y? The product would be 4 times 3, 12, or 1 times 0, 0. Now, if that was too much, and you're like, is there an easier way? Yes, there is. You could quickly, and I'm pretty sure whatever calculator you get, you could handle this. I could quickly graph these two. Now the window, if the window doesn't show those intersections, oh, okay. I happened to get a window that did. If it didn't, you could just do zoom standard. And you can see that they cross. You could do trace, and you could move over to where they cross. You can kind of see that they're crossing at 1, 0. If you type in 1, enter, there's one of your intersection points. Now the other one may not be as easy to see. 2, 3, 4. Let's say I think it's 4. I type in 4. There's your other intersection point. So that's another way to do it. Whatever makes you happy. I would say go for something like this, graphing or algebraically, because it's something we spent a lot of time on. Hopefully you feel comfortable with that. Okay, 30 and 31 are looking at this table. In 2006, and I'm going to go quickly, I know it's been a long video, the price of king crab was $8 a pound at the beginning of the year, dropped to $7 a pound towards the end of the year. So 2006 is this bar right here. Okay, and at the beginning of the year it was $8 a pound. At the end of the year it was $7 a pound. Okay, if 60% of the king crab supply was sold at the higher price and the rest was sold at the lower price, what's the total revenue generated in millions of dollars? And this bar graph is in millions, so I'm going to do this without writing out all those zeros, because when we put this answer into the grid in, you can't put that many digits. You're going to have to put it in millions. Okay, so I'm going to figure out if 180 million pounds of king crab was sold, 60% of that would be 0.6 times 180. So 0.6 times 180, 60% was sold at the higher price, which was $8 a pound. So I'm going to multiply 0.6 times 180 to get 60%, then multiply it times the $8 a pound, and see what that is. And then I'm going to add that to whatever the remainder of this is. So I could just type in 0.4 times 180 times the lower price of $7 a pound. There's more than one way to do this. Whatever is going to be the fastest. 0.6 times 180 times 8. Okay, there's the 60%. That was sold at $8 a pound. Now I'm going to add the 40%. There's the revenue in millions of dollars. So you would put, I feel like that's going to be too big. It is going to be too big. Okay, so you have to round this one off. Okay, so you have to round this off. You don't have to round this off. You could just put in 1368 in the grid in. There's 4 spaces. Because that's the answer. It's $1.368 million. This is already in millions. So that's what you would put. So the real answer is this. But you can't put all of that in your grid in. Okay, in 2011, the price of king crab was $17 a pound. In 2012, we don't know how many million pounds of king crab were sold at $16 a pound. If the total money generated from sales was the same, how many pounds did they sell? What was the value of X? So I'm going to say, see that in 2011 they sold 80 million pounds of king crab. So 80 times $17 is, if the revenue is the same, that's going to be the same as however many million pounds of king crab they sold in 2012 times 16. So if I'm solving for X, I'm going to divide both sides by 16, and 80 times 17 divided by 16 is 85.